So, as you probably heard, we're going to talk about today about IoT botnets. First of all, who am I? I'm a senior security researcher at IXIA, and I spend most of my time working on identifying new threats in the wild, monitoring botnets, researching new malware and the like, and I manage a gang of honeypots online, which is a bit of a handful sometimes, but it's pretty nice. You can get a lot of info from this. So today we're going to talk about, as I said, about Mirai, a bit of information about components, a bit of an analysis of how the botnet works, how the communication works, and everything like that. And then we're going to see how we can actually go about tracking the CNCs and some stats from our research. So, first of all, what is Mirai? Well, considering the number of people here, I suspect that you probably know about it. So last year, Krebs Security was attacked by, let's say, stressors of DDoS with about 600 gigabytes, which was off the scale considering what we've seen, what it was before that. What was really interesting from the report from Akamai is that they said that it wasn't let's say usual DDoS, the standard DNS amplification or SYN flooding or whatnot. They said it had a lot of they'd seen a lot of GET requests, pull requests, HTTP requests, which gave them the information that they're not dealing with, let's say, the standard DDoS generated by some DNS or whatnot. Instead, they said it was most likely that they were dealing with a very, very large bot with a lot of devices connected to it. So, after everything cooled down for a bit, a week and a half later, the source code was uploaded to GitHub. Thank you, John Gambino, if I'm not mistaken, his name is. Well, this was actually good from a security research point of view because we had all the code necessary to start analyzing this threat and looking into it. But it was also bad because a lot of people with malicious intents actually had the chance to get the hold of the source code and build their own botnets, and that actually happened. A lot of people started doing this, and since then we've seen an increase in the number of attacks against let's say IoT devices. So, as for high-level components, Mirai is basically comprised of the bot itself, the one that basically is a piece of software that resides on your infected device. It's interesting that it supports multiple architectures. It's MIPS, ARM, x86, and so on. There's a loader, which basically harvests the successful logins. Once the bot starts running, it starts scanning for new vulnerable devices. When it finds a vulnerable device, it takes the information, that IP address and the credential combination, username and password, and sends it back. Once that happens, it connects to the new device, downloads the new software, and so on and so forth. And so that way, basically get a huge network of devices that are doing non-stop brute forcing with default credentials and everything. There's also the website hosting the bot malware. Basically, when they infect a new device, they log in and they try to basically just pull the binary there, run it, and go on. And lastly, one of the most important pieces of the architecture is the CNC server. Once the bot infects, the device starts scanning, it will automatically connect to the CNC server and wait for commands. What commands? DDoS, that's what it does. The CNC server also has an operator panel, which works on a different port than the server for the bots where they connect. So this is basically a representation of how the botnet works. So we have the infected IoT devices, which turn and brute force your, let's say, DVR or CCTV devices or whatnot. Once they manage to find the credentials to log in on that machine on Telnet, they report the results to the loader. Once that happens, the loader logs in on the machine, fingerprints, and you need this to know what architecture the system works on, so they know exactly what binary to download. They load the binary from the website, and then they just basically join the horde, let's call it. And once that happens, the CNC, the operator of the CNC can basically say at any point start doing DDoSing some targets, whatever, and all the machines basically just do that. So a couple of information about the bot. There's some interesting features around this. When you run it, it actually you can only run it if you use a specific file name. So if the binary isn't called DVR helper, you don't run it with /DVR helper, it will automatically stop. It will just delete itself off disk, forks, and then just stops. If you use that particular file name and you execute it correctly, it forks, changes the process name. So if you do a PS and try to look for that process for DVR helper, you're not going to see anything. It is interesting that you're going to see, however, the socket. So basically, it's opening up a server, and you'll see those, and you can actually find the process that's running the bot there. But that obviously connects to the CNC server, waits for commands, and at the same time, it continues, it starts scanning for new hosts to infect, and that does that non-stop. So the bot has an output state table. It's basically XORed. Initially, if you try to run strings on it, you won't see much information from there. But if you use the XOR key, which was generally used as 0x deadbeef, you'll actually be able to extract information about the CNC, the reporting server, ports used, and everything like that. Even the default user agents they use for HTTP requests and the like. So as I said, the XOR key is actually only 1 byte. It's 0x22. That was in the beginning. At some point, we actually started seeing some changes, but it's being a 1 byte XOR table. It's practically super easy to write a script that will automatically try to find the key. You can just look for some specific strings that you know that are going to be there. For example, you can look for user agents. If you're going to do this, you run the script to deobfuscate it. If you find, for example, the user agents or some other known information in there, you can just, you found the key in the obfuscated binary. As I mentioned, the bot has scanning capabilities in order to discover a lot of other devices that it can infect and use for DDoSing afterwards. It basically, when it starts scanning for new targets on port 23 and 2323. Once it finds a machine that has one of these ports open, it will automatically try a list of default of user and password combinations to log in. The list of user and passwords was actually found there. I think there were like 60 combinations, and later on, after a couple of months, I think they actually updated. There was some info on that. They actually updated it with new users and passwords. What they did basically is something that most of us do without actually, let's say, thinking about it. When you get, for example, as an end user, when you get let's say, a router or a DVR or something, you try to set it up. The first thing that you do is search Google default username and password for this device. So what they did was basically comprise a big list of these users and passwords, put it in the binary, and it tries those combinations. Another interesting, let's say, item in the bot itself is that when it starts scanning, it sets the TCP sequence number equaling the destination IP address. So if you'd like, for example, to set up a monitoring on your device and see if you're getting, let's say, there's attempts from Mirai, from the Mirai botnet to scan you or to brute force you, the quickest way is to just inspect those TCP sequence numbers. If it's equal to your public IP address, then it's a pretty clear sign. Interestingly enough, this was also used later on in the IoT Reaper. A lot of info was, well, actually not that much info was published on the IoT Reaper. Initially there was a big hype, then kind of quieted down. But there's a lot of similarities between the IoT Reaper and the Mirai botnet. For example, if you look at the code of the bot, you can actually see, for example, there was a rickroll, a YouTube link to a rickroll put by the hackers in the beginning, and you can actually find that same URL, the same rickroll in the Reaper as well. The difference is, of course, that the Reaper, when it started scanning and trying to infect new devices, it didn't use, let's say, default credentials. It actually started using some known vulnerabilities in DVRs and network attack storages and whatnot. I think there were 8 vulnerabilities, and it uses those one after the other one. So when it finds a target that has, let's say, port 80 open, it starts using all of these exploits until it manages to get a foothold in. Also, when the botnet starts scanning and it actually gets the foothold in first, it does a fingerprint for the as a busy box system. Basically, it's looking for if the target is actually a vulnerable device or not. If you're, let's say, if you run this in a honeypot or let's say a classic Linux machine, these commands, for example, bin busy box, are not going to work. But if you respond with, for example, Mirai applet not found, it's going to say, okay, passing this check, moving on. Moving on to the loader, basically what happens is it reads from the standard input and connects directly to the IoT devices. And after that, once it has the foothold in, it uses commands like wget or TFTP. Sometimes I think we've actually seen curl, for example, being used in order to download the binary, do the busy box discovery. And another interesting feature is that it uses, it runs cat on bin/echo in order to discover the architecture of the system. So you might actually pass all these other fingerprinting techniques, but if you don't have the correct echo binary on your machine, it's not going to work. And based on this information, it actually goes to the website hosting the binaries and downloads the one that fits that particular architecture. And of course, as mentioned, it changes the name to the VR helper and then executes it. This is a replay of a log from one of our honeypots. Basically, when you run the binary, you get everything, all the steps from fingerprinting all the way to wget, basically downloading the binaries, renaming, changing permissions, and then executing. In this case, it failed. But this, if it does not run this way, it will automatically fail. So in terms of network connectivity, what it does in order to communicate with the CNC, basically, since it's pretty easy to actually connect to the CNC, you just have to send the initial sequence, and then it's all heartbeats, which is 0x00/x00/x00. You'd have to do this every 60 seconds, and you basically stay connected to the botnet. You can listen to whatever's going on there. The attack message format, length, the duration of the DOS, etc., etc. We'll see a couple of examples here. The options. Here we have some examples pulled from our logs. Targets, duration, attack type, UDP. What else? ACK, UDP plane, HTTP. what domain to target, and so on. So they have actually about 8 attack types. What was interesting is that this particular one, at least this one caught my eye, for example. It's called Valve Source Engine Playfoot. And for those of you that might not know, Valve is basically the company that developed, let's say, Counter-Strike. So this is actually a pretty interesting piece of information. So they're actually trying to DDoS gaming servers. And some of the logs actually, we've seen that they're trying, for example, to hit a domain called NFO, I think, Nuclear Fallout Game Servers or something like that. They're basically a hosting server for Counter-Strike and other games. Other than that, UDP flooding, DNS, sync flooding options, HTTP, generic routing encapsulation, HTTP, which can do basically even either get requests or post requests with junk data. So, aside from Mirai, which was, let's say, the biggest, let's say not player, but the biggest name in this field last year and this year, there are other threats as well. So one of the ones that we've been seeing is Yavgate/Bashlight, Kyton, Tsunami, IRC Telnet, and IoT Reaper. Most of them pretty much work the same way. They brute force credentials, get in there, download binaries, connect to the server, and infect other machines in the process. The difference is that some of them have different CNC, let's say, communication protocols. Instead of having, like the Mirai has this specific communication protocol, others use some stripped down IRC servers, others just plain telnet. You can just connect there, and once you do the telnet to the server, it automatically sends the command to start scanning. Well, except for the IoT Reaper, which is using exploits. So, for example, this is a script that will be used by DefCamp to automatically download binaries and run them. This is an interesting thing because the difference being is that Mirai tries to fingerprint the system and identify which binary to download and execute. In other cases, they simply just spray and pray. They download every binary for every architecture and run, and whichever one runs, that's fine. One of the nice, interesting thing that also found in IoT Reaper as well as in Mirai, they're very, let's say, territorial. When you run it, if you try to run two binaries one after the other, they'll actually kill the initial process. So there's only one instance of them running. If you try to run multiple instances in a single VM, for example, it's not going to work. Only one of them is going to be alive at a time. So we get to the point that, let's say, we want to start tracking the CNC. We want to see what they're doing, what attacks who are they attacking, and so on. So what we did was extract the URLs from the honeypot logs, downloaded the binaries, and then started looking into them. There were two options here. We can either run them in the sandbox, or you can write a tracker for these. And we did both, of course. The thing is with sandbox execution is you need to be very careful about firewalling your VM, because if you don't do that, you'll end up having a VM which is basically brute forcing other vulnerable devices across the internet, and you don't want to do that. The advantage here is if the bot binary changes its behavior, it can actually, you don't have to actually worry about that, because the binary is there, it's doing what it's supposed to do. If it pulls any updates, it will continue working correctly. However, we found a major disadvantage in using the sandbox for this purpose, and that is scaling and performance. Being able to run only one binary at a time is a major drawback, considering the number of, let's say, exploit attempts and the number of binaries that we were seeing. So we chose to join the horde. We basically wrote a tracker which respects the communication protocol of the Mirai and Kyton and whatnot. We just start connecting to each of these servers as you find them, and see, and you can actually, let's say, confirm them by the commands that they're issuing first. If they send, for example, a scanner on, you know you're dealing with Yahoo, for example, because that's the command to start the telnet scanner. The advantage here is that you don't need very many resources for this. You can basically have a script, a piece of software that connects to these servers, and just have to be careful to respect the protocol. And you can also connect to a lot of them simultaneously, or you can just deploy it on multiple machines across the internet so you don't get blacklisted. And problem is, once the behavior of the CNC changes or the protocol changes, you always have to go back and, let's say, update your code so you don't stay behind, because otherwise you'll just be taken out of the botnet because of this. So here we have some info, some of the most interesting stuff that we've seen while monitoring these CNCs. So as you can see here, it's basically is ordering the bot to start the scanner, ping, ping, ping for the keep alive, seeing some UDP flooding, and then we see some people chatting. And we see that they're doing these Kellogg's, they go to work, they have to sleep, they're going to talk on Skype later on, and so on. And some other guys, Tanner and Cam. Interesting stuff also. For example, you can actually see during these chats that these people were posting their bot counts. So in the beginning, when you're seeing these, they were having like 10,000, there were CNCs that had 10,000 bots connected to them at one point. However, later on, most of them were struggling with getting 2,000 bots at a time. Also, operators scheming, trying to scheme other operators. What's basically going on? They're thinking of sending their botnet network to somebody else, and then flood the server and take those bots back, and get the bots back, while getting some money first. Other interesting stuff that we've seen, actually, a lot of people, some of the CNCs actually had Twitter accounts tied to them. You'd connect to the CNC, and yet you could actually see people posting their Twitter accounts or some Instagram accounts. So this is information that I think is valuable, because it gives us a sense that these people aren't, let's say, very professional. They're not very careful with their data, with what they're doing. They're not very careful if they don't even realize that somebody might actually be listening to them. And from a bit of research that we've done afterwards, we found, for example, we started looking at some of these Twitter accounts. Most of them were just, let's say, teenagers that used these bots in order to DDoS gaming servers, because they got 360 no scope in Counter-Strike, whatever. Some info on stats. We've collected about 5,000 unique binaries over a 6-month period of time. We've identified and confirmed over 200 CNCs, and we've seen just over 700,000 attacks against these 100 bots. Some statistics about the bots themselves. Most of the attacks are coming from the United States, which isn't, let's say, that big of a surprise considering the number of devices there. Then Netherlands, Russia always present, France and China being, let's say, the top. And as for targets, again, leading by a very big distance is the United States, Germany, Russia, and others. As I mentioned, that while looking into these people, you can actually find them on Pastebin. This guy has an account which has a lot of info about Mirai, about other bots, kits to actually and tutorials, on how to install and run these botnets, from Mirai to Kiten to variants of these and so on. They even have GitHub, so you can find the code easily. And also Twitter. This is actually a screenshot from one of their posts. Can't see it very well here, but this is actually the operator panel, the admin panel for Mirai. And during some other chat they had on Twitter, somebody was pretty upset that the server had been taken down at some point, and he wanted his money back. So that's it for me. Follow this guy on Twitter. He's one of our colleagues. He's helped me. He's one of the ones that's been working on this project. He's a really, really smart guy, and he posts a lot of interesting stuff on Twitter. Follow Chuck.